This is MATHguide.com, and my name is Mark Karadimos. This video is going to derive the product rule for derivatives, and we're marching right in. So let's say that you have h of x, and h of x is a product of two functions. What we're going to do is, of course, figure out how are we going to take the derivative of this product, the derivative of this product of functions. So, okay, well, first of all, we know that the derivative is as h approaches 0, we take this function and we replace the x's with x plus h. And then we subtract the function. All right, now I'm trying to write small because there's going to be more to it. So this is what the function looks like. Now algebraically, there's really not much we can do with this. So what I'm going to do is get a little tricky. So I'm going to extend this fraction, and I'm going to place something here that later will make it very convenient for me to be able to simplify this. All right, so let's say I put a, how does this go again? That's right, x plus h, g of x, minus an f of x plus h, g of x. Okay, so what did I do? I took the numerator of this fraction, I added and subtracted the same exact expression. Why? You're just going to have some patience, and you'll see why this is kind of nice to use. All right, so marching on. Now it's just a matter of being able to arrange this in a convenient fashion. So let's put this first term, leave it right where it's at. Okay, so I left that right where it's at. Now what I want to do is put this subtraction right next to it. Okay, then I'm going to put the plus next to it. You definitely have to have patience when you see this, because really when you see this, you rarely know where this is headed. All right, so I have this entire numerator and an h in the denominator. Of course, we're taking the limit as h approaches 0. All right, so what I want to do is take this right here. Let's see, should I do, you know what? I should do this, right? I'm sorry, I want to show a little bit more detail. What the heck? This way there's no sneak attack. All right, so what I want to do is take this huge expression and I want to break this up into two fractions. Okay, so I put these two as one fraction, and then here's going to be another fraction. This f of x plus h, g of x, minus f of x, g of x, all over h. Now, of course, we're taking the limit of this entire thing as h approaches 0. Remember that it's kind of strange that when you see a fraction and you break up a fraction into two parts, it's a little strange because although it comes up a lot in these higher level math courses, it's not natural. Normally you take two fractions, put them together as one fraction, which you can do when you have a common denominator. You just add the numerators. So I'm just working backwards in that process. Okay, well, if I take a look at this first part, if I take the limit as we approach this, well, I'm not going to take the limit yet. I'd like to, but take a little bit of work here. Notice that they both have this f of x plus h, so I'm going to rip it right out of there. So if I factor that out, what's left? I have g of x plus h minus g of x. Starting to get sloppy here. I got to be careful. Okay. So this is one thing. When I take the limit of this, but remember I just took out a factor of f of x plus h. F of x plus h there. Okay, got that. So let's do the same thing if I take the limit of this, but I'm going to take out the g of x out of this one. So I still have the limit as h approaches 0, but I'm going to take out the g of x. And now what do I have left? I've got f of x plus h. Let's see, I took out the g of x, so I've got f of x. And in the denominator, I have h. Okay, now to be able to see what's happening, I'm going to make a little bit more room. So I'm going to scroll down, scrolling down, scrolling down. That should be enough room. So I wanted to create some space here because I wanted to leave a little room to show you a graphic. So if I were to take the limit of this right here, right? If I take the limit of this expression, this is really g prime, right? This is the derivative of g. Look at that. I got x plus h minus the x there. You know, this fits the pattern right here of the derivative of h, derivative of g. So far, I'm getting is the limit as h approaches 0 of this, that's g prime. But now if I take the limit as h approaches 0, in other words, if this is 0, 0 plus x, that's just plain old x, that's f of x. And I'm multiplying these two guys together. Just a regular multiplication. Okay, now what do I have over here? If I take the limit as h approaches 0 of this expression right here fits the pattern for, yep, you guessed it, f prime, the derivative of f. Okay, but let's see, h goes to 0. Well, there is no h here, so that's just g of x. And there you go. I have this relationship. Now, sometimes people write this relationship like this. They say f of x times g prime of x. And then they say over here they have f prime of x, g of x. So they keep things in order, f of g, f and g, f and g, except you take the derivative of the second one times f of x, the first one, then you add the derivative of the first function times the regular function, second function. Anyway, there's two different ways to write the same relationship, and I think the second way is a little bit more commonly written. Okay, there you have it. So please like the video, please subscribe to the channel. Go back to mathguide.com, check out our lessons, check out our interactive quizzes and our instructional videos. Thanks. Take care.